All right, we should be live for World Quant Office Hours 2, Week 2, first office hours of the week. Let's go ahead and kick things off. Hope everyone is doing fine today. We left in September and now we're already October 4th. All right, so I see Abu Bakr. Hello, Abu Bakr. I see Jay Gaudreau. Nice to see you back here, both Abu and Jay. I see Emmanuel. Familiar name. I see Badagessen. Welcome back, Badagessen. I see Raydot. Welcome back, Raydot. Hope everyone was doing fine this week. I'm doing pretty good today so far. And let's see who else is joining us. And I think last week we did a lot of cool stuff. Getting comfortable with the scikit-learn syntax and working with that scikit-learn API. If we're going to use that language there. And now I think we've covered enough of that background material. We've already had weeks 1 video and now you've given weeks 2 video. I think we've covered enough background material that we can start looking into the mini projects. I think we're at that phase now. We can go ahead and crack those mini projects and make progress on that front. I see Ramsey is here. Welcome back, Ramsey. I see a couple unfamiliar names, but that's perfectly fine. I see GZ is here and Waisu is here as well as Raul is here. Welcome everyone. Welcome to Office Hours. I think it's time that we can start cracking and making progress on the mini project. As always, floor is open for things we want to bring up and our best prioritize. Let's go into machine learning. Let's go into mini project. Let's go into ML. The very first mini project. See, Joseph John is here. Welcome, Joseph John. Run the cells, as always, import the static grader. Let's go ahead and look what this is asking us about. So the objective of this mini project is to exercise your ability to create effective machine learning models for making predictions. So we're going to be in the realm of supervised learning. I see Suleiman has a question here about the distance transfer. I do not think you actually did what the question required us to do. That could be very much the case. Create features for the distance away from Los Angeles and San Francisco and include them in the original features. Please look into this. Okay, well, let's, I guess that's a kind of a pressing matter right now. So I can look at ML scikit-learn. And where is it? All at the bottom about custom estimators, customer aggressors. So I can do cell, run all. So we look at the exercises here. The California housing data set has features for latitude and longitude. Create a custom transformer that returns features for the distance away from a given set of coordinates. Use this custom transformer to create features for the distance away from Los Angeles and San Francisco and include them with the original features. How much better does the model perform? All right, so let's take a look at that. Maybe I did make a mistake in the videos. Perfectly could have happened. I see another question there. Let me just, before we delve into that, let me see more what's going on here in the chat. I see Ramsey saying, I have a carryover question from last week with the min-max scalar. Could you please clarify a bit about the series versus parallel transforming? So what we've done so far, is parallel transformations. In other words, we have a step here. We have a second step. We have a third step and so forth until we arrive at a final predictor. So here I just have a 3-step process where I have 2 transformers, T1, T2. So this is carried out in series. So these transformers are one after the other. Of course, in our problem, we were deciding whether we should have min-max or standard. It wasn't that we were using both of them. We were not using both of them in the final model. We used grid search CV to help us out to determine which one was better. We ran the experiment with min-max and we ran the experiment with scalar. Our ultimate model just used one of them. It didn't use both of them. It used one of them. So we ran the experiment to determine which was better, min-max or scalar. And what we realized from here is that we cannot statistically say that one was better than the other. That was our ultimate conclusion. So we just chose the standard scalar because it technically had the slightly better average. But we know those results weren't statistically meaningful. So ultimately, we just relied on one transformer, our scalar. I think our process was just a two-step process, but nowhere did we talk about parallel steps. Nowhere did we talk about parallel transformations just yet. We'll get to that to more complicated workflows like we'll see in the mini project. Welcome manual. So let's go back to here in the exercises here. So I want to create a custom transformer to find distances from Los Angeles and California. So what I can go ahead and do is say class, let's say from class, and I can say dist transformer base estimator in transformer mixin, base estimator transformer mixin. What I need, I'm going to outline what I need here. I need to calculate the distance from a set of coordinates from our data from San Francisco and LA. So I need the coordinates for LA and San Francisco. I also need a method, manner, equation to calculate distances. I think that's all I need. Kind of a sketch on my outline what I need here. So I'm going to create a custom transformer that will calculate the distance between a coordinate, one of our observations, to LA and San Francisco. So what I should probably do here is I should probably have an init method here. A init method that one can specify the coordinates, what to calculate the distance from. I don't want to hard code if it should be San Francisco or LA. I'm going to let the user specify that coordinate when they create an object of that class. So what I'll do here is accept origin. And self.origin equals origin. So that's what I've done here. I'm creating a class that one can specify the origin point. Of course, we got to flesh out the rest. We'll do that coming up. Questions right now about this init method before we flesh out the other methods? All right, do let me know. So let's go flesh out the fit method. So I have the fit method here. Accepts x and y, and I don't really need y, so I'm going to set that to none. So in the fit method, I see Mickey Rat. Hello, Mickey Rat. In the fit method, put a little comment here. Here goes any. Here goes the code for the model to learn from the data. In other words, here we calculate and determine any model parameters that we will need in the transformation. So in the fit method goes any code, all the code here about how one can go about calculating parameters that will thus then be used for transformation. That's what the fit method is going to contain. And I feel like the best way to answer this question here and figure out what the fit method needs to be, I actually think it's maybe more logical that we first write the transform method. And as we write the transform method, we become aware of what are the parameters that we need to learn from the data that should be in the fit method. Think about what these algorithms are doing underneath the hood is they take data and they calculate parameters from that data. That's what's the learning. That's the learning in machine learning. Where we give it data and it learns a set of parameters. It calculates a set of parameters from the data. And those parameters are then used for transformations or predictions. So I'm actually going to not flesh out the fit method just yet. I'm going to say pass as a placeholder in Python. I'm actually going to flesh out the transform method. I think it makes more sense to do the transform method first. And here is how we transform the data. And what I want to do is I'm going to calculate the distances. I'm going to make an approximation here. There's equations out there that we can follow, that we can look up on Wikipedia to calculate distances between coordinate points. We can go ahead and use those formulas, but you know what? We're going to be dealing with maybe not distances that are not too far away from each other, so we can just simply treat latitude and longitude as sort of x and y. We can get away with that approximation because our distances are not going to be too far away from each other. All right, strictly speaking, we should probably rely on some sort of method to calculate the distance between our points more properly using some sort of equation that we find on Wikipedia. But just for simplicity's sake, just for right now, let's just treat latitude and longitude as if we're x and y coordinates. If we have x and y coordinates, then we can calculate the distance between an origin point. That origin point was stored in an attribute of the object called origin. So what I can do is I can say x, yeah, simply a Euclidean distance, exactly. So I can take my x of my data, and I can say, well, x, I'm going to access column 0, which is sort of the x coordinate, and I can divide that. I always forget which one's latitude and longitude. I always forget. So latitudes are this way. So this is our y. Lat is y. And longitude are up and down. All right, approximating, doing an approximation, very distances not too far away from each other. And long is x. So what I should probably do, I'm going to write my code to expect that what comes into this transformer are two columns, where the x is first, the long, followed by the y. So I'm going to assume here that the data, let's assume that the data comes in as two columns, where the first is my longitude and the second is latitude. So let's do x minus, I can say self.origin, and I express, look at LA coordinates, probably Los Angeles. Now for this exercise, we can probably just get away with what's contained, what we get from a quick Google search, Los Angeles coordinates. I know I typed in news by accident. And there's the coordinates of Los Angeles. So let's go ahead and use those. I'm going to copy this north. So this is latitude is first, and typically latitude is always shown first. So let's go ahead and make this conversion. I think it's going to stick to the convention that it's actually latitude is first, then longitude. Latitude and longitude. I believe that is a strong convention we have for coordinates. So we subtract self.origin 0, and I'm going to go ahead and just create a new cell here. I'll call this origin LA. It's an iterable, so a tuple would be fine. Perhaps makes sense because I probably don't want that to be mutated. And since we have a negative coordinate, since it's west, we make sure it's negative there. So I have a tuple with the coordinate point LA. And here I just calculate the difference between x and y, self.origin 1. And I should probably square this plus this other one here. Square that, and then take the square root. I can calculate dist. .5. All right, I see Yash is here, and I see someone pointing out how that WhatsApp, Facebook, and Instagram are down. I guess we have an internet outage. I guess we're not affected. I guess we're not affected. I guess that's good. All right. So this is calculates the distance. It's just a very simple approximation. We're not using any fancy calculation for distance and coordinates. We could. And the problem, I'm going to return dist. I'm going to return dist. We're not quite done yet. Any questions so far? Any questions so far? We still got to go back to the fit method. Remember we said we're going to come back to it later. We said let's do transform, and then we can go and call fit. All right, so it looks like WhatsApp, Facebook, and Instagram are all down in Bangladesh. Well, they're all owned by Facebook, so maybe that's that's related. So, any questions we'll have? I know there's been a lot of. Wouldn't be surprised if it's maybe intentional. Someone perhaps brought Facebook down, maybe, because I know they've been getting a lot of negative attention as of recently. I'm not going to take a stand on this here. I'm going to go ahead and stay neutral in that situation, but maybe they've taken it down. But luckily our forum, right? We still have our board, right? Q board. We still have YouTube. And our board is still open. Still up. That's good to hear. Good to see. It looks like maybe Zuckerberg accidentally deleted it, right? Oops, right? Undo. Anyways, all right, yeah, we can talk more about hyperparameters. Yes, we can talk more about hyperparameters. So do let me know specifically, or I can go ahead and introduce them as we go throughout these exercises. So now let's go back to the fit method. Let's go back to the fit method. And I said here the fit method are going to contain the code that we go about applying to calculate certain parameters are used for transformation. And there needs to be, I see, needs to be conversion between degrees to distances metric. Strictly speaking, yes. But I'm just making a very simple approximation here. Very simple approximation. If the points aren't too far away from each other, I can go ahead and just treat them as simple x and y coordinates. Not true. Of course, we have a latitude and longitude are very much different. Right? The longitude are always the same lengths, and latitudes get smaller as they go up to the equators. And then we have the Earth. The fact that the Earth is round and not flat. But this is just a very simple approximation that we can go back and update as we have something that works. So let's not concern ourselves about do this properly. We can go ahead and do that at a later time. But going back to the fit method, let's go back to the question we posed and we didn't quite answer. Was, are there anything that we need to learn about our data that was required in the transformation? So my question to you, was there anything that I needed to use in the transformation that I would have learned from the data? And what is that? Yeah, just a proxy right now. We can go ahead and fix it up, of course, and I do want to properly fix it up. Is there anything that I had to use in transformation that I would have learned in the fitting process, in the training process? What was that, if there was any? Anything I need to learn from my data that should be in the fit method? It actually turns out there's nothing we need to learn in the fit process. Nothing that we need to learn. In other words, we can carry out that transformation without having to learn anything about our data, learning anything from our data. That can happen. If that's the case, we make sure we return self. Never forget to return self. Yeah, there's nothing. In fact, that's why I rewrote the transform first, because if there was anything that we need to learn from the data, we would have said, oh yeah, I need that number that I would have gotten when I trained the model. So sometimes your fit method is nothing. However, you need to return self. You need to return self. Never forget. It's a very common mistake. Never forget. Because scikit-learn, in order for you to have this transformer play nicely with the scikit-learn infrastructure, for this we're creating here to be compatible with the other tools of scikit-learn, it needs to return self. In the implementation of scikit-learn, how it's going to take these transformers, or these estimators in general, because it's not just a transformer thing, it's an estimator thing in general, it needs to return self. So you might get some cryptic errors if you don't return self. The fit method, even if there's nothing to learn, must always return self. And now we have our very first transformer. Let's go ahead and play around with it. So I have my data. I guess I call it xtrain perhaps, if I recall, maybe xtrain. Well, there, maybe it's just called x. So we didn't do a train test split. So I could say dist transformer equals dist transformer. I say origin. Let me give the origin for LA. Dist transformer. Call fit and transform. I'm going to select. Let's see what columns they are. Let's say data. That's not too helpful. Should probably call print of that. And the latitude and longitude are the last two columns. Okay. Probably can do something like -2 and -1. And there are my distances. I've calculated my distances. Now I've hard-coded those columns in. The one thing I need to be aware of is that we need to make sure that our transformed data, is returned as a 2D array. And at the moment, it's a 1D array. So we'll call reshape, and I can verify that by calling shape here, and it's a one-dimensional array. It needs to be a 2D array. So little idiosyncrasy of scikit-learn. I want to transform the data as a two-dimensional array. So I say, give me how many rows I need to have one column. And now if I run that there, I have a two-dimensional array. There is my two-dimensional array of distances. Of course, it's a proxy right now. We got to perhaps fix it up. But nonetheless, let's not worry about that right now. We can come back to it later and improve on it. But now we've got a distance transformer. Fit transform, was there such a function? So someone brought up the fact that, hey, I use this function called fit and transform. This method, to be more precise. But if I look at my class definition, nowhere do I define fit and transform. What's happening here is that it's inheritance. It inherited from one of these two classes. This custom class is not derived from scratch. It is not a class we derived from scratch. We created classes in Unit 1 from scratch. Remember that VC mini project? Where we create those classes from scratch? Here we are creating classes not from scratch, but by inheriting some sort of base template. By inheriting a template that we can add to. So even though we don't see this fit transfer method, it was inherited from one of these two parents. Specifically, it's going to inherit it from the transformer mixin. So here we see, good question, here we see the concept of inheritance. And we need to do this. We could have probably gone away with creating a custom from scratch, but we might have caused issues down the road. Because it was sort of things may work out initially, but when we start bringing this tool, this new class, into the greater scikit-learn ecosystem, things might break down because we didn't inherit from these two classes, base estimator, transformer mixin. So that's where that comes from, because it inherited from the transformer mixin. In fact, I can probably say something like transformer mixin NC fit and transform. So it does transfer. We see how it does have its fit and transform method. All right. Other questions? Let me know. Can we actually call transform without fitting since we do not put anything onto it? Ooh, good question. So Mickey is saying, wait a minute. In this case here, can't we just call transform? Can't we just call transform? So theoretically speaking, it's nothing has to be fit. And this actually, yeah, you can get away with it. You don't have to do it. We can get away with it. However, it's probably good practice that we call fit and transform just in case we go back to it and indeed we have to fit it. Not indeed we have to fit it. Indeed we have to do something else besides return self. It might cause problems down the road. But strictly speaking, there was nothing in our custom class where this would have caused an error. Okay, other questions people have? Okay, do let me know, but I'm going to continue here. So, can you show the method fit and transform? We probably look at it, right? We can probably look at the source code. Let's see. Let's see if we can see the source code of it. Well, there is the file right there. So I guess we could look at that, right? So open up a terminal, and I'm going to go to that direction where that file is located. Opt conda lib python 3 site packages sklearn. There's the file base. Let's take a look at that. Let me search fit and transform. And there it is. It's calling fit, and then it's calling transform. Nothing too simple. Nothing too complicated. Calling fit, and then transform. Now you see why fit needs to return self. Because internally, the fit and transform method assumes that the fit method returns the object itself, returns a copy of itself. Because it's going to do chain methods. It's going to chain two method calls together. So if fit didn't return self, it returned none, for example, then this would have been none.transform, none attribute error. Or if we somehow return the data instead or something like that, then it's going to have an attribute error. So now we see why in the internals of the source code, why we need to return self. Okay, let's see what else is happening in the chat. And remember, the whole point is that we have to look at the source code because it inherited from the transformer mixin. If you have a pipeline, would it create new 1D arrays for every process, or would it create one and then work on that? So the internals, I'm guessing it's not going to create copies of the intermediate transformations. I'm assuming it's going to keep on. I guess there is no reason to keep track of, there is no reason to have hanging around in memory copies of the intermediate transformations. I'd have to look at the source code to properly answer your question, but looking at sort of design principle, what's good practice, I'm guessing scikit-learn isn't going to say, I'm going to keep track of each intermediate transformer in memory. It's probably overriding the reference, so it only has the raw data, which it's leaving untouched, and is mutating a copy, is modifying a copy of it instead. Okay. So questions we'll have at this moment here. All right, so I'm going to go ahead and continue on, but do let me know. So I have this transformer. It's calculating distances, and we said maybe we can come back and revisit the actual equation. But now we got to go back to what the question is asking us to do. We want to calculate, we want to have a data that has the original columns and 2 new columns for distance between LA and San Francisco. Okay. Well, then what we got to do, let's sketch that out. Let's sketch out our process. So here comes our raw data. And I want to include 2 transformation steps that will occur in parallel. One for LA and one for San Francisco. So these 2 are going to be distance transformers, but I want to glue the results together. So there are parallel transformations. 2 parallel transformation steps. But I also want to ensure that the other columns, the other 6 columns, are able to safely travel through. The 6 other columns. So this is what I want to occur. I want to have 2 distance transformer objects. One for LA, one for San Francisco, but I also want to ensure the other 6 columns can continue on the workflow, can continue on downstream. So I want to take this process here and wrap it as a single step, a single transformer step. So what I've got to do is, let's see if we can play around with some of the tools in scikit-learn to achieve this. So what I'll first do is I'll say dist LA. Well, let me say origin LA and origin SF. Get the coordinates for San Francisco, so I'll copy that, paste it right there, and make sure I make this negative. There we go. There are my coordinates. And then I will create my 2, I'll say, all right, I'll do that there. What I'll do next is I'm going to import from sklearn, compose, import column transformer. Let's use the column transformer now that we're using a more modern version of scikit-learn compared to what's on the videos. I can say my selector, say column transformer, and I give it a list of parallel steps. So I'll call one of them dist LA, which is going to be applying the distance transformer with the LA coordinates, and I want that to be applied to 2 columns, which are indeed the last and the second to the last. And now things are going to get a little hairy in terms of parentheses, so I'm going to break this down. It's a little easier to read right there. So what I've said here is that I want to select these 2 columns, the second to the last and the last. So let's see if this works out, if it can accept negative coordinates, or negative indices. This is a transformer to apply, and we're going to call that step dist LA. We'll create a second step called dist SF, distance transformer, origin SF, and apply it to the last 2 columns. And then finally, we want to have those 6 remaining columns continue on through the process. So I'll call this else, as in everything else. Probably come up with a better name. Since I just want those to pass through without any transformation, I'll just say the pass through. It's a special string that scikit-learn will recognize. That this means just to let it pass through. Let it pass through. Don't modify any, don't transform those columns, pass through. And then here I can specify what those columns are. And those are columns 1 through not 7 and 8. So 1 through 7 should be suffice. And now I'm ready to go. But I'm going to break this down a little further because I know you may have not seen this step here, with this tool here. This says I'm going to have a single step, a transformer that's going to select certain columns of my data and apply selective transformations on that data. So I give it a list of tuples. A tuple represents a parallel step here, a parallel step, not in series, in parallel. So I will apply this transformer on these 2 columns. So these are the indices of the 2 columns, second to last one, and we'll call this dist LA. Apply this other transformer for the San Francisco, we'll call it dist SF, instead of lack of originality. And which columns? Columns 1, 2, 3, 4, 5, 6, and not 7. So I used a range there for convenience. I could have given a list or a tuple of explicitly. Let me run that cell here and let's see if it runs. Who knows? Who knows? Transform X. I get a not fitted error because, well, I forgot to do fit and transform. Fit and transform. I get a value error. No valid specification of the columns, only scalar list or slice of an integers or strings or Boolean mask is allowed. Okay. So let's see. One of these steps is wrong. Let me go ahead and comment things out just to know which one is broken. It probably doesn't like a range object. I have to give it, I'll say slice instead. There we go. I give it a slice. Just for you to know what a slice is, right? Slice, we haven't really built into Python. My list, 0, let's say -1. Hello there, hi, world quant. You can say my list can slice 1 and 2. It'll give me there. So this says give me a slice from index 1 all the way to 2, not including 2. So it's a nice little convenient thing I can do. It's a slice object. It's built into Python. So now I put that there. I call it transform, and this should have 8 columns. And it has 8 columns. The first 2 columns are the transformations, and the last 6 columns are the original data. The original data except for the latitude and longitude. And there, I think I have it there. So does this give us 2 columns, each with twice the number of rows? The number of rows stays preserved, right? Because you're simply going to be modifying columns. The rows get preserved. We're not going to add new records. We're just selecting certain columns and adding columns. So this here has, this creates 1 column. This here creates 1 column, as we saw above, and this here creates 6 columns. Oh, I should probably say slice 7, because I want to include the 0 index. So actually, no, I get 9. Let me go back to what my data has. What did my data have? Maybe I was messed up somewhere. My data has 8 columns. 2 of those are latitude and longitude. So I can take the second to the last one is latitude, longitude. Okay. So where did I mess up on my math? So slice. So I want columns 0, 1, 2, 3, 4, 5, 6, but not 6 and 7. There we go. My mistake there. 8 columns, so we go up to indices 7. So I want columns 0, 1, 2, 3, 4, 5, but not 6 and 7. So I do slice of 7. And this should create me 7 columns. I think I'm off. I am off. I still don't realize where I'm getting off by. Let me just try that. If I say 6 all rows slice of 7, unless slices deviates. Okay. I see. Slice. Let me look at the documentation of slice. Right? I have some issue with that. I rarely use slice on a day-by-day basis. It's not something I use daily, so I forget how it works. So let me just pull up the documentation. Start, stop, start, and creates a slice object used for extending slice, for example, 0, 10, and 2, and a step size. The documentation is left to be desired, right? Plenty left to be desired. So let me just see if I can call list of slice 7. And let's say for val in slice, so it's not an iterable, so let me just play around with that. If I say x slice 2, so by playing around with it, it looks like slice is really inclusive. Just by playing around with it. Okay, well that's a little bit annoying since it sort of deviates what we're used to in Python, but that's fine. I would say slice of 6. And now I have it to work out. Now I have those 8 columns. I have the 6 original plus 2 additional ones that I created that are about the distance between LA and distance from San Francisco. Or as Mickey Rat pointed out, I could have been more explicit, right? I was trying to be fancy here and avoid doing too much work. But apparently this caused more work by debugging the issue. So I could have just given an iterable, a tuple of the columns 0, 1, 2, 3, 4, and 5, as Mickey Rat pointed out. But I wanted to be fancy and use slice, but I apparently have egg on my face now. Right? That's what happens when we don't do things don't use certain things too often. You forget how they work. A little peculiarity there, but I think we've solved it. So any questions right now? Should probably put this in a proper office hours notebook, so I'll probably do that after office hours and make that available. So I probably should have worked on it on a different notebook, but oh well. I'll do that later after today, or after office hours at the very least. Okay. All right. Questions, follow-ups. I think that takes care of the exercise and what we needed to be done. Of course, we put it in a transformer, put it in a pipeline, and everything else. Let me just out of completion do that, right? Out of completion. Probably should create a train test split. I have my model from sklearn, pipe, import pipeline. So what I have next is after this step here, I will have a scaling step, the scalar step, followed by a predictor, followed by a prediction step. So what I have here, interesting enough, is I have the first step, which are really 3 steps in parallel that I wrap using the column transformer, so it's a single step in terms of scikit-learn, followed by 2 additional steps, scaling, predict. And I want to wrap these together in series, so I use a pipeline. So now you can see how we can create rather arbitrary, not arbitrary, and how we can see how we can create complicated workflows in scikit-learn with tools like column transformer and pipelines. Put steps in parallel, put steps in series, so that we can have a single estimator object. A single estimator object is going to be a lot easier to deal with and not have to bookkeep and track of all those intermediate steps. So I'm going to go here. So pipeline, I'm going to create my model. And the first step is my selector, and I'll just call it selector for a lack of a better word. My selector step. There goes my selector. My next step is my scalar, so I'll call scalar there, and I need to import a scalar, so I'll just use pre-processing import standard scalar. And then my last step is my predictor, my regressor. So I'll call that regressor, and I'll use linear regression. I create my model. I can do model.fit on X train, Y train, spelling counts in Python. And then finally I can say model.score X train, Y train. Well, that's how well I do on training. Let's see how well I do on testing. And not too different. And I forgot what I got without adding that. Kind of go back here and probably see where it was. Let's see. Do we have a benchmark on how well it did before anything else? Let's see. I think I do. I think we do. Yeah, so it looks like let me just run this, because we should probably have done it on the same data set. We'll call this model, we'll call this model dist, right? Probably come up with a better term for it. Oh well. And before, we just called it model. Let's actually fit on X train, Y train to make a fair comparison. So it looks like adding these new columns don't really improve our performance. But that's why we run these experiments. I see a question here, right? Maybe we can use a better model than linear regression. I see a question here. How are series and parallel operations syntactically differently? They're syntactically differently because notice in this setup here, the first thing we do with our data is we create a column for distances from the house to LA, another column about the distances between the house and San Francisco, and then we preserve the other columns. And these two steps occur, these three things occur in parallel. They occur parallel. Then we scale, but scalar has to be afterwards, because how do we scale the data before we even have those columns? So we see how it manifests itself in scikit-learn, that in scikit-learn, to have transformers in parallel, we use a tool like column transformer. To have transformers in a series, one after the other, we use a pipeline. So when you sketch out your workflow, parallel steps you wrap in a column transformer. And steps in series you wrap in a pipeline. And you can have pipelines that with column transformers in pipelines. Very much nested structure. With these two tools, you can build arbitrary complicated workflows for your task. So your question about the syntactically difference is just we use column transformer for in parallel, pipelines for in series. Because if you look at the code, we have a list of steps. We also have a list of steps here. It just knows that this is a column transformer, so they're in parallel. And this is a series, so they're in, so the pipeline, so they're in series. So someone is saying, how to execute the exact formula? How do you execute the formula? When you say execute the formula, what do you mean by formula? What formula are you talking about? Let me know what you mean by the formula. Other questions people have? We're spending all office hours on this here, but I think it's a lot of stuff to talk about here. I'm a newbie, so I'm putting code in, but can't run the code to get out. I'm putting code in, but I can't run the code and get out. You have a specific example there? Let me know. I'm going to look at other questions here. If you write scalar min-max after scalar, would it be series or parallel? It would be, well, it depends. Are you using pipeline or using column transformer? Pipeline, so here, pipelines put steps in series. So it doesn't look at him and say, oh, these should be configured this way. Column transformer, these put steps in parallel. So that's how you know. Put steps in parallel, column transformer. Put steps in a series, pipeline. About additional resources beyond the documentation of scikit-learn, then I don't know. I don't know on top of my head any additional resources beyond the documentation of scikit-learn. But if I do, I will let you know. Can you please explain the last parameter in column transformer? I will do. What's the difference between a column transformer and a feature union? And do you have in 19, for example? How do you get 96 out? So how do you get 96 out? Well, because when I ran this cell, this here returns, it's going to display what I've created, so it displayed what I created here as an out. Right, this here returns the model itself. So I guess I could have assigned it to a variable, but since they're mutated, I don't have to. So it's not anything different from us using Jupyter Notebooks for other situations. All right, can you explain the last parameter in column transform? This step here, this here. So how did you run it? I did shift enter. Shift enter or the play button. Just like I would run any other cell. So Rat Nandeep, did you mean this last step here and specifically this here, this slice? Yeah. So this here, these two steps create two columns, Distance to LA, distance to San Francisco. But remember the original question said, I want to keep everything else. I want to keep everything else just the way it is. So in order not to lose them, I tell column transformer that I want columns 0, 1, 2, 3, 4, and 5. And I think this should have been, should this have been 5? Now I'm confusing myself once again. No, I guess it's 6. Create 6 columns. Because I want column 0, 1, 2, 3, 4, and 5. I guess it's inclusive, exclusive. Now I'm really confused. Perhaps I could have saved myself a lot of heartache if I just said 1, 2, 3, 4, and 5. So what I'm telling here is I want to keep. That's what pass-through represents. I want to keep these columns. Columns 0, 1, 2, 3, and 4, 3 and 4, and 5. Because columns 6 and 7, they're going to be transformed to create 2 columns. Distance LA, distance San Francisco. So the syntax is the name of the step, which is arbitrary. The transformation, but if there's no transformation, you can say pass-through. And that last thing here, last bit of information, is the columns you're referring to. Here, these columns, -1, -2, is because in order for me to calculate the distance, I need 2 columns. I need latitude, longitude. And those were the second to last and the last column. So hopefully that clarifies your issue there. That goes into the question about the difference between a column transformer and a feature union. And then I say, what if I play neither the play button nor the shift enter? Is it working? Right? I have to, once I write the code, I have to run it, right? Once I write the code, if I just write it, I need to run it. So shift enter to run it, or the play button to run it. I need to type my code, and I actually need to run it. Right. Very much not too different from the stuff that you saw in Unit 1. Right, hopefully through Unit 1 you've learned, how to pretty gut home down how to work the notebooks. Same thing in Unit 2 as we use these notebooks. So once again. So now the question becomes what's the difference between a column transformer and a feature union? Not too much different, in fact, these days. To the point that feature union is still around. You might need it every so often, but feature union is kind of useless these days, right? Feature union in scikit-learn is kind of useless these days. So what feature union would do before is feature union was a way to combine transformers in parallel. But what feature union didn't have was a way to select the columns to undergo each of the transformers. That was the difference, the main difference between a feature union and column transformer. Because previously you would have to create your own custom estimator, your own custom transformer, like we did in the old videos, to create a selector step, a transformer that would select certain steps, and then with feature union. But nowadays you can use a column transformer instead, which you can specify apply this transformer to these columns, hence the name column transformer. So because of that, it's not as useful these days. I believe still in the mini project, we can do it, I think, both ways. It's a little, let me think about that. It's a little annoying the way the grader works, the way that column transformer works, that we're kind of forced to use feature unions. So unfortunately, we'll have to use feature unions in the lecture, in the mini project, but they're sort of useless these days, a feature union. So we are out of time today. I think we did a good job explaining this. So tomorrow we'll open up the mini project and make progress there and touch upon certain topics and hopefully get more comfortable with the tools of scikit-learn and also what's going on behind with machine learning. So that's it, everyone. Take care. Hello, math lecture. Take care. Have a good rest of the day and see you back here.